Lesson 7. Solving Linear-Quadratic Systems. When given the equation of a linear function and a quadratic function, you can find the point of intersection of the two systems. So if you have a linear and a quadratic, you might want to find the point of intersection of the two systems. The two systems may never intersect, may intersect at one point or at 2 points. So your systems could intersect at no points, 1 point, or at 2 points. When they intersect at 1 point, the line is a tangent line. When they intersect at 2 points, the line is called a secant. So if they intersect at 1 point, the line is a tangent line. If they intersect at 2 points, the line is called the secant. Before you try to find the points of intersection, you may first wish to know if there are any points of intersection. So you might want to know if there are any points of intersection first. You can use the discriminant to see if a system has 1, 2, or no points of intersection. So we use the discriminant to check how many points of intersection a system has. It can have 1, 2, or no points of intersection. The formula of the discriminant is b squared minus 4ac. So the formula for the discriminant is b squared minus 4ac. If the discriminant is less than 0, there are no solutions. So if the discriminant is less than 0, we have no solutions. If the discriminant is 0, there is one solution. If the discriminant is greater than 0, there are two solutions. So if the discriminant is less than 0, there's no solutions. If the discriminant is 0, there's one solution. And if the discriminant is greater than 0, we have two solutions. And it's important to know here that b squared minus 4ac, these are the variables from the standard form of the quadratic equation. This is the standard form of the quadratic equation. So a is the coefficient of the x squared variable, b is the coefficient of the x variable, and c is the constant term. So b squared minus 4 times a times c is the discriminant. So now let's look at this graph. Here we have a quadratic curve, and we have two lines. This line touches the quadratic curve at 2 points, 2, 7 and 1, 13. Therefore, this line is a secant line. This line touches the quadratic curve at 1 point, 1, 13. Therefore, this line is a tangent line. And it's tangent to this quadratic at this point, 113. Let's look at a sample linear quadratic system and see if it has no solutions, one solution, or two solutions. Suppose we are given the following equations. Y equals 3x plus 5 and y equals 3x squared minus 2x minus 4. First, equate the equations. So set the equations equal to each other and move everything to one side. Equate means to set everything equal to each other. 3x plus 5 equals 3x squared minus 2x minus 4. Now move everything to one side. We move it to the right side because 3x squared is already positive on the right side. So 3x squared, then we move 3x to this side, so it's minus 3x minus 2x, which is a negative 5x. And we move positive 5 to this side, so we have negative 5 minus 4, which is negative 9. Next, determine a, b, and c. So as you recall, this is the standard form of the quadratic equation, with a being the coefficient of x squared, b being the coefficient of x, and c being the constant term. So we will use these to determine the discriminant. So we determine 3x, we have our equation, 3x squared minus 5x minus 9 equals 0 from here. And now we just determine A, B, and C. So A equals 3, B equals -5, and C equals -9. So A equals 3. A is the coefficient of the x squared term. B equals -5. B is the coefficient of the x term. And C equals -9. C is the constant term. Now plug in the values of A, B, and C into the discriminant b squared minus 4ac. So A equals 3, B equals -5, and C equals -9. B squared minus 4ac. We plug in -5 for B squared minus 4 times A, which is 3, times C, which is -9. -5 squared is 25, minus 4 times 3 is -12, times -9. Then we do -12 times -9 is equal to 108. Positive 108. 25 plus 108 is 133. Since the value of the discriminant is above 0, the line intersects the quadratic function at 2 points. So because the discriminant is positive, the line has 2 points of intersections with the quadratic. Therefore the line is a secant line. Therefore we have a secant line. To find the coordinates of the 2 points of intersection, equate the equations and then simplify. So to find the coordinates of the 2 points of intersection, we equate the 2 equations and then simplify. Afterwards we find the value of x. Afterwards we find the values of x. Finally, plug in the values of x into either of the original equations to find y. So in the end, we plug in the values of x into either of the original equations to find y. Let's go through an example. Find the coordinates of the 2 points of intersection for the following quadratic linear system. So we have y equals 2x squared minus 10x plus 15, and y equals 9x minus 15. So first equate the 2 equations, make them equal. We set this equal to this. So 2x squared minus 10x plus 15 equals 9x minus 15. Next, simplify. You bring 9x to the left side. So negative 10x minus 9x is negative 19x. And positive 15 plus 15, because we bring it to the other side, is positive 30. Now you have a quadratic equation. Solve it. So we notice that negative 19x is equal to negative 4x minus 15x. And we know that 4 times 15 is 60, and 2 times 30 is 60. So we can use factoring to solve this. We factor out 2x, and we factor out negative 15. So in this case, you can use factoring to solve the equation. So in factoring out the 2x, we factor out 2x, we get 2x times x is 2x squared times x minus 2, because 2x times negative 2 is negative 4x. Here we get negative 15 times x, because negative 15 times x is negative 15x. And negative 15 times negative 2, because negative 15 times negative 2 is positive 30. So we get negative 15 times x minus 2 equals 0. Notice that x minus 2 is equal to x minus 2. So we can factor this. We factor by keeping x minus 2 and then doing 2x minus 15 as the second bracket. So 2x minus 15 times x minus 2 equals 0. So now we isolate for x. We set 2x minus 15 equal to 0 and x minus 2 equals to 0. And we solve for x. So x equals 15 divided by 2 equals 7.5. X equals positive 2 here. Now we must find the y-coordinates for the 2 points of intersection. So next we have to find the y-coordinates for the 2 points of intersection. To do this, substitute each x value into either of the above equations. To do this, we substitute each x value into either of the above equations. The points of intersection are located on both functions. So we note that the points of intersection are located on both functions. Let us pick the equation that is easier to work with. Y equals 9x minus 15. So out of these two equations, we pick the one that is easier to work with, which is this one. Y equals 9x minus 15. So for x equals 7.5, we substitute that into y equals 9x minus 15. We get 9 times 7.5 minus 15. We get 67.5 minus 15. We get y equals 52.5. For x equals 2, we get y equals 9 times 2 minus 15. We get y equals 18 minus 15. We get y equals 3. Therefore, the coordinates of the 2 points of intersection are 7.5, 52.5, and 2, 3. And 2, 3. When doing your homework, you may find a special type of problem which provides you with a quadratic function and a tangent line along with its slope. So when you're doing your homework, you might find a type of problem which gives you a quadratic function and a tangent line along with its slope. You'll be requested to find the y-intercept of the tangent line. To do this, write the equation of the line in slope y-intercept form. So the first step is to write the equation of the line in slope y-intercept form. You'll need to work with two equations. So you'll have to work with two equations. The equation of the line and the equation of the quadratic. The equation of the quadratic function will already be given. So note that the equation of the quadratic will be given to you in the problem. Use a variable, such as b, for the y-intercept. So we use a variable, such as b, for the y-intercept. Then equate the two equations and simplify. Then we equate the two equations and we simplify. Next we find a, b, and c in the discriminant b squared minus 4ac. So the next step is to find a, b, and c. Once you've done this, you'll be able to use the discriminant b squared minus 4ac to find the y-intercept. So once we've done this, we can use the discriminant b squared minus 4ac to find the y-intercept. This will all be clear when we go through an example, which we'll do next. To make things easier, let's go through an example. The tangent line with a slope of 4 intersects the quadratic function y equals 1/2 x squared plus 2x minus 8 at only one point. Find the y-intercept and write the equation of the tangent line in slope y-intercept form. The first step is to write an equation for the line in slope y-intercept form using a variable for the y-intercept. So the first thing we do is write an equation for the line in slope y-intercept form using a variable for the y-intercept. Let us use b to represent the y-intercept. So we write y equals mx plus b. This is slope y-intercept form. And this is the equation of a line in slope y-intercept form. And the slope is 4. So we simply substitute 4 for m. And we let b represent the y-intercept. Next, equate the two equations. Y equals 1/2 x squared plus 2x minus 8, and y equals 4x plus b, and simplify. So the next step is to equate. 1/2 x squared plus 2x minus 8 equals 4x plus b. Then we simply simplify. So we bring everything to the left side because 1/2 is the coefficient of the x squared term on the left side, and it's positive. So we bring 4x to the left side, we get minus 2x, because plus 2x minus 4x is negative 2x, minus 8 minus b equals 0. Place brackets around constant terms to isolate them. Remember, b is a constant term. So here the last step is just to place brackets around minus 8 minus b. Because if you note here, ax squared plus bx plus c equals 0 is the standard form for the quadratic equation, and c is the constant. And notice that it's plus c. So we have to have a plus sign in front of the constant. So we put the constant in brackets, and we keep a plus sign in front, and that's c. So the constant is minus 8 minus b. And that's because minus 8 times plus 1, there's an invisible 1 here. Minus 8 times plus 1 is minus 8, and minus b times plus 1 is negative b. So this is the same as this. 1/2 x squared minus 2x plus, in brackets, negative 8 minus b. Next, we must find the values of a, b, and c in the above simplified equation. So the next step is to find the values of a, b, and c in the above simplified equation. This will allow us to work with the discriminant. So finding the values of a, b, and c in the above simplified equation will allow us to work with the discriminant. So we have here the equation of the quadratic formula. We have the equation of the quadratic in standard form. Ax squared plus bx plus c equals 0. So we have this equation now. 1/2 x squared minus 2x plus negative 8 minus b equals 0, which is the same equation as this. Therefore, a equals 1/2. A is the coefficient of x squared. B equals negative 2. B is the coefficient of x. And c is the constant term with a plus 1 in front, but the 1 is invisible. So c is equal to minus 8 minus b. That's the value of c. Now let us plug these values into the discriminant, b squared minus 4ac. So the next step is to plug these values into the discriminant, b squared minus 4ac. Remember, the value of the discriminant for a tangent line is 0. So the value of the discriminant for a tangent line is always 0. Consequently, we can set up an equation that will allow us to isolate b, which represents the y-intercept of the tangent line. So what we're trying to get is the y-intercept of the tangent line, which is b. And we can isolate b by setting up an equation, knowing that the discriminant has a value of 0 for all tangent lines. So we begin. A equals 1/2, b equals negative 2, and c equals minus 8 minus b. The discriminant is b squared minus 4ac. We let that equal to 0 because the discriminant for a tangent line is always 0. And now we simply substitute. Negative 2 squared minus 4 times 1/2 times minus 8 minus b is equal to 0. 4 minus 2, because negative 4 times 1/2 is negative 2, times minus 8 minus b is equal to 0. 4 minus minus 2 times minus 8 is positive 16. Negative 2 times negative b is positive 2b equals 0. 4 plus 16 equals 20. 20 plus 2b equals 0. 2b equals negative 20. b equals negative 10. Therefore, the y-intercept of the tangent line is negative 10. The equation of the tangent line in slope y-intercept form is y equals 4x minus 10. And that's all for lesson 7, solving linear quadratic systems. Stay tuned for chapter 2, transformations of functions, and for lesson 8, functions and equivalent algebraic expressions. If you liked our lesson, be sure to like and subscribe, and also leave a comment down below. Thank you.